Hello, my name is Saurabh. This is an introduction to a series of tutorials on writing code for computational fluid dynamics. That is, creating your own CFD software for simulating fluid flows. I have some experience in coding CFD software, so it's just an attempt to share this knowledge and also to document the same for myself. The obvious question which arises is, why is this tutorial required? Well, I have spent a lot of time searching for such a tutorial for CFD and I was unable to find one. There are few very nice lectures from Professor Strang and from Indian Institute of Technology on YouTube, which explain the mathematical aspects of CFD, but not on how to implement these concepts. That is exactly what these tutorials will focus on. I will be using only finite volume method as it is a very well established method for CFD and can be extended to unstructured mesh naturally. The code structure and data structure is the backbone of any program, making the algorithms easy or difficult to implement. So, we will spend some time on what a good code structure and data structure should be, based on my experience. Starting from simple one-dimensional codes, we will go to more complicated 2D and maybe 3D problems. High-resolution reconstruction methods will be used as it is well understood that low-order methods are not capable of accurately capturing features like vortices or shocks and other high-gradient flow structures. High-performance computing aspects will be used wherever applicable at a later stage after completion of codes. Well, I must also say what this tutorial is not. Since I am from aerospace engineering, I mostly deal with compressible flows. Therefore, we will not look at pressure-based methods like simple or incompressible flows. However, similar programming practices can be used there as well. Also, incompressible flows can be tackled using a technique called artificial compressibility using the same methods as used in this tutorial. Java will be used for coding all the algorithms using NetBeans as the IDE. IDE stands for Integrated Development Environment. It is just a platform which will allow us to easily do our coding. Python will be used for plotting and visualization using Spider as the IDE. The version control system Git will be used for continuously backing up the code so that we can retrieve older code in case of any mistakes we make. Git will be used from within NetBeans, which provides a convenient way to handle Git repository. In addition, I will be using softwares like Exornal, Inkscape, Record My Desktop, Kdenlive, Lex, LaTeX, and Audacity for making these videos and post-processing. We will follow a logical sequence starting from 1D scalar PDE to full 2D system of Euler equations for structured mesh, slowly extending our code a little at a time. Many of the concepts used for structured mesh can be used for unstructured mesh as well. However, we will rewrite our code because many of the classes and objects have to be modified to handle unstructured mesh. But the advantage of using unstructured mesh is that we will be able to handle any complicated geometry. At that point of time, we will also write our own unstructured mesh reader. Throughout this series of this tutorial, we will keep comparing our solutions to analytical and numerical solution from literature to make sure that we are on right track. I am creating such videos for the first time, hence please provide me with suggestions related to software or otherwise for improvement of these tutorials. I will be creating and uploading as time permits, but I will be creating these videos mostly during my weekends. so I will try to upload at least one video every week. Okay, see you soon.